Alright, so we got something else cool we're going to show you. You can barely see, and I'm going to go ahead and move this camera. You can barely see that my two top lights are barely lit.
We added in a third bulb.
We added in a third bulb, and those other two top lights are completely dim. Now,
Still lit, but dim.
Now we're going to show you what the power division is on three bulbs and two different sizes. I know you saw that. The different sizes of bulbs is going to affect the power being delivered. All right, so Mike goes ahead and does the same thing again and stretches from the positive here.
We go to both sides. We're at 13.7.
We're at 13.7. He starts there and he goes to this one. He's stretching across the entire deal and showing that all three bulbs are consuming that 13.7 volts. But if I come down here and look at this bulb,
it's taking 9.4.
This one little bulb is taking 9.4 volts of that 13. So that's only leaving me 4 volts, just over 4 volts to separate between these two bulbs. Now let's see what they're pulling. Accumulatively, these bulbs
4.3
are taking up 4.3. Individually, we're looking at 2.15, 2.2, somewhere in there. So,
check this bulb now and see if it's pulling any more power.
This one,
because it comes first in the line. Nope. Oh yeah, it was pulling out 2.2. Even the other one was going back. 2.1.
Right. So we still have one of these bigger bulbs pulling in a little bit more than the other, but relatively speaking, we're having a difference of this bulb consuming the majority of the power here. Now that has to do with the bulb itself. This bulb has way less resistance than these two bulbs. So because it has less resistance, it's going to be able to pull the power a lot easier. Now,
it's still being cycled through the relay.
It is still being cycled through the relay, right? And you see I pulled this out, this one bulb completely, this is in series, which shows me pulling this bulb out. If this was on a truck and I wasn't sure, pulling this bulb out and noticing that all the other bulbs died, that would indicate that we are in series, meaning I have to have a connection for this to work. I'm switching the small bulb up to the top. And yet again, it's pulling the majority of the voltage.
So now we have the big bulb down there.
Still 9.4. And yet again, that just indicates that this bulb is lit easier and is able to consume more power than the rest of them. So when you have an unlike bulb in a circuit that is in series, that is designed to have a particular size, and you throw in something random, this is the scenario you're most likely going to come up with because you have different resistance values. Electricity takes the flow, the path of least resistance, and this little teeny tiny low resistance bulb is going to consume the power due to the fact that it's easier to go through. And yet again, thank you for watching Time of Mike's Garage.
Thank you.